Okay, so let's take a look at number 9. Find the total area of this weird 3D looking shape that kind of looks like a short fat pencil. So let's see what we can figure out here. This thing, now you kind of have to assume certain things about it, like that this right here is half of a sphere. And this guy, here, I'll put this on top actually. So this right here is half a sphere. This right here is a cylinder. And this is a cone. Ugh. Come on now. Cone. Okay. Let's see. We know that the distance from top to bottom, well, maybe side to side, I suppose is a better term, because really I'm going to tend to think of this as the top and that as the bottom. But it's 6 across. Well, a really good place to draw in part of that 6 would be right here. That's 3. Right, so the radius of these circles here is 3 and 3. Well, this thing's half a sphere, and if the radius of that is 3, then this is also 3. Now let's see, we're looking for total area. Let's come over here and kind of think about what total area is going to be. Now, if this thing's a pencil, then those circles you can't actually touch because those are on the inside of the pencil. So if we break this thing up into the 3 chunks, we've got that outer part of the sphere, of the half sphere. So that's just going to be half the area of a sphere. And then we've got this cylinder in the middle, but I don't want the total area of the cylinder. I just want the walls of the cylinder because the top and bottom of the actual cylinder are stuck inside the pencil and I can't touch them. So I just want these walls going around the edges here. So plus the lateral area of a cylinder. And then I've also got the cone here, but again, I don't want to include the actual circle itself in the area. I just want the walls of the cone. So I'm going to add in the lateral area of the cone. Okay, so half the area of a sphere, that's going to be 1/2 4 pi r squared. And we know that the radius is 3 here, so it's half of 4 pi 3 squared, which comes out to be, let's see, we're doing this in exact form. What is that? 18 pi. So this is the half sphere. Okay. The lateral area of the cylinder. So let's see, lateral area of a cylinder, that's perimeter of the base times the height of the cylinder. So that's going to be, let's see, perimeter of the base. Now you have to think of the cylinder like a sideways cylinder turned. So it's like this cylinder here where this is 3 turned sideways. So the perimeter of the base is going to be the circle, which is 2 pi r, 2 pi 3. But I don't have the height of the cylinder. I don't know how long that thing is yet. So we're going to have to come back to this. So let's see. Let me actually move this over here. Okay, so this part we're not sure what this is yet. It's 6 pi times h. And then I got the lateral area of the cone. So lateral area of a cone is given by 1/2 perimeter of the base times the slant height. So that's going to be 1/2. And then the perimeter of the base here, so think of the cone like this, right? The radius is 3, so the perimeter of the base is the circumference, which is 2 pi r. And then the slant height is 5. So if we work that out, that ends up being, let's see, the 2.5 cancel, we're left with 15 pi. So I still need the h. Well, here's the thing. I know that this part down here is 3 because that's this. If I knew this part, that would be this right here. So we can actually get that. If I call that x, I know that 3 squared plus x squared equals 5 squared. And if you work that out a little bit, x squared then ends up being 16, so x is 4. So this length right here is 4. Well, the whole length is 18. And if I take away 3 and I take away 4, I'm left with 11 in the middle. So if I turn that sideways, that means that the height of the cylinder is 11. So this, going back to the cylinder, it's 2 pi 3 times 11. So that's going to be 60. Come on, pen. 66 pi. So I've got 18 pi, 66 pi, and 15 pi that I need to add together. And if you put those all together, you end up with 99 pi. Okay, let's also try number 10. So number 10, we've got a sphere that's circumscribed around a rectangular box. The length is 10, the width is 5, and the height is 7. Now, and they're asking for the radius of the sphere. Now, it's impossible to really draw this perfectly, but the idea is that this is actually touching the sphere. So, like, it's kind of like, I don't know if I can sketch this or not. So, all 4 of these points are actually on the sphere, just like down below, too. These guys would all be touching the sphere as well, those 4 corners on the bottom. So I'm going to get rid of this because that's kind of complicated to see. But it's sort of like if you could perfectly fit this box inside that sphere, all 8 corners of it would be touching the sphere itself. So the question is, what's the radius of the sphere? That's the main thing. And then the area of the sphere is just plugging in the radius into the area formula. So there's a hint. How's the diagonal related to the radius? Here's a diagonal. Cuts right through the middle of the thing. So this is actually a diameter of the sphere. So if I can find out how long the diagonal is, I could just cut it in half and have the radius. So let's see if we can make a right triangle to work with here. So if I actually go right through the middle here, that forms a right triangle. The 10 and 5, think of it like the ground, and this triangle's sticking up and is just stuck in the middle of the entire thing. So first, let's take a look at this segment here, which I'll call X. So if I draw the base of the box by itself, looks like this, 10 by 5. It's a rectangle, and that's X. I can solve for X. 5 squared plus 10 squared equals X squared. So that's 150 equals X squared. So X is root 150. Okay, so this is root 150. And it's kind of hard to see the 7 that I put there earlier, but there's the 7. So now I've got this big triangle to work with. This is, and it's floating in the middle of that box there. This is 7. This is root 150, and this is the diagonal of the box. So I'll call that D. So I've got. Oh, I'm sorry, I messed up. That's not root 150. That's root 125. My bad. There we go. Now it's right. Okay, so to get the diagonal, I'm going to do 7 squared plus root 125 squared equals D squared. That's 49 plus 125 equals D squared. And if I take the square root, D ends up being root 174. So then the area of the sphere, oh, I'm sorry, that's not the radius, that's the diameter. So the radius is root 174 cut in half, which, if you plug it into a calculator, it's about 6.595. Okay. The area of the sphere is given by 4 pi r squared. So it's going to be 4 pi root 174 over 2 squared. Well, we could do decimal form for this if you wanted, where you plug in the 6.595. This one actually works out decently well. Root 174 squared is 174. 2 squared is 4. And then those guys cancel and you're left with just 174 pi. So that also works. But let's see. Let's just get the decimal anyway, because my guess is most of you are doing it that way. 546.637. All right. Hope that helps a little.